Hi, Algebra 1 students. This video is just want to go over a few topics that were the frequently missed topics on the Chapter 3 test. And so this is recommended or required, depends on your teacher watching this video, to prepare for a retake. Okay, so this is the paper test review. If you have it, I suppose you could take notes along with this video. If not, you could take notes on paper. Remember, you can always pause the video. First of all, a relation to a function. Most people did fine when you had a graph, so you did vertical line test. Remember, when you have a table or coordinate points, what you're checking for is there, for a single x, is there two y values? So each x can only have one partner, if you want to think about it that way. So if you look at this one, my x's never repeat. So this would be a function. And if you look at this one, -4, -2, 0, 2, 4, 6, these are all unique x's. And so each x has only one y partner. So that would be a function also. So something that would not be a function would be, say, a table that looked like this. And remember, f of x is just another way of writing y. So say I had 2, 0, -2, 4, 1, 7, -2, 6, right there, where I just repeated those x values. That says that -2 is paired with 4 and -2 is paired with 6. Nope, cannot have that. So this would not be a function. Okay, now, discrete versus continuous. Discrete, first of all, this is a discrete graph. Discrete graphs, notice to draw them, I have to lift my pencil. Okay, now let me show you the difference. This is a continuous graph, so this one is continuous. Continuous means you can draw the entire graph without lifting your pencil, right? I just did it right here. Discrete graphs, there's no way you can draw all these points without lifting your pencil. So that is the difference between discrete and continuous. So somewhere in your notes, put continuous. I can draw the graph without lifting my pencil. That's the best way to remember that. That's the way we remember it in calculus. Domain and range. Domain are your x's, range are your y's. So for a discrete graph, it's going to be a list of x values. And if you just look at all of these individual points and find their x values, that's going to be your domain. So my domain is going to be 1, 2, 3, 4, oops, I missed one, 5, 6. Each of those discrete points. So you list them. And range is going to be a list of your y values. So this is a great way to do this for discrete. Okay, so these are the y values. Looks like I have, oop, wait a minute, I have this one and this one. So I have 0, 1, -1, 0, 1, 2, 4, and 6. Okay, if they repeat, did we have a repeat? If they repeat, you only list it once. So, and you have to start smallest to biggest. So -1, -1, 0, 1, 2, 3, 6. -1, 0, 1, 2, 3, 6. Okay? Discrete domain and range. Continuous domain and range is going to be continuous, which means I'm going to have the big x values and y values, if you want to think about them that way, the whole numbers, but then every little increment in between. So every little decimal between -1 and 0 is still part of my domain and range because the graph is discrete, or the graph is continuous, sorry. So I would say domain is x's. Start out by writing, whenever you have a continuous graph, write that for your domain and write this for your y with the equal to. Inequalities to the left, they always need to be pointing in the same direction. Smallest x value here, biggest x value here. Smallest y value here, biggest y value here. So now let's go to our graph and think. Here is the kind of the left side of my graph, and if I go down to the x-axis for my domain, the smallest x value is a -1, and the biggest x value is a 2. And my domain can be any point in between -1 and 2. So both of these are closed circles, so I'm going to do -1 and 2. Now, range are your y values. I like to think domain tells you how wide your graph is. Range tells you how tall your graph is. So think, where's the bottom of my graph? Here's the bottom of my graph right there at y equals 0. Where's the top of my graph? Here's the top of my graph right here at y equals 4. Bottom to top is range. Smallest y value is 0. Biggest y value is 4. Okay? Remember, if you happen to have an open circle up here, then you just wouldn't have the equal to up there. Okay, so continuous and discrete domain and range. Those were definitely ones that were missed a lot on the test. Now I'm going to go right over to some graphing ones. This one we would graph by intercepts. So remember, for intercepts, I always say do the cover-up method. So I'm going to cover up the y value. Let me do it with my pencil here. Cover up the term that has the y and write the equation with your leftovers. So if you think about covering up the plus 2y, what I'm left with is x equals 8. Well, guess what? That is your x-intercept. If I cover up the term that is the x value, I'm left with 2y equals 8, and then I solve for y. Divide both sides by 2, so y equals 4. That's my y-intercept. X-intercept, go to the x-axis, put a coordinate point at 8. Y-intercept, go to the y-axis, put a coordinate point at 4, draw a line. Those are nice ones. Okay? Slope-intercept form, m is the slope and b is the y-intercept. So if you have something like this, the number multiplied by the x, or the coefficient of the x, is your slope. So your slope would be 1/2. The number hanging off the end that isn't multiplied by the x is your y-intercept. So my y-intercept would be -6. Take that sign in front of it. It's attached. It's part of the name of that 6. So y-intercept is -6. So for example, in this equation, first of all, find the coefficient of the x, or the value number, or the number multiplied by the x. It's 3/4. That's your slope. Number hanging off the end is 2.